Hi everyone, my name is Santiago. I'm a senior student of University Tecnológica de Pereira from Colombia, but currently I'm doing an academic exchange in the University of Kentucky. Today I'm going to talk about breast cancer classification using deep convolutional neural networks. According to US breast cancer statistics, in 2020 an estimated 270,000 people new cases of invasive breast cancer are expected to be diagnosed, and 40,000 women are expected to die. And despite the existence of screening programs worldwide, the interpretation of mammograms is affected by high rates of false positives and false negatives. Moreover, convolutional neural networks were used because they constantly preserve the spatial structure of the image. With regard to the challenges in this area, radiologists face two kinds of problems every day. The first one is caused by low detection sensitivity in mammograms, and the second one is caused by the nature of breast cancer. The problem of using FIFI-DM is because the overlap of dense fibroglandular tissue over the suspicious lesions. On the other side, malignant and benign abnormalities are too similar between them. For these reasons, the research aims at developing a CADD tool using image preprocessing techniques and deep convolutional neural networks. This tool will be used as a second reader to help improve radiologists' performance in the diagnosis and overcome the low sensitivity of current screening techniques based on mammographies. The scheme consists of four steps. The first one includes preprocessing methods to improve image quality. The second one is about selection of area of interest. Third stage is about the extraction features. Finally, the extracted features will be used to fit a learning model. This model will be classify abnormalities as benign or malignant. This time, the MIAS dataset was used. In the image preprocessing and segmentation model, a morphological opening operation was used to remove the background, and the contrast was increased through discrete wavelet transformation. Finally, the image was binarized using a thresholding technique. As can be seen, the abnormalities are fully identified. However, this approach is not appropriate because we took advantage of the coordinates of abnormalities made by a physician. But according to the scheme proposed, it should be an entire autonomous system. This is why, before to explore all stages, we decided to experiment a baseline model which uses raw mammographies. Each model is from Kaggle and is composed of three parts. The first part consists of pre-trained BGG16. It is followed by an attention mechanism to turn pixels in the global average pulling on and off. Finally, there is a classification layer of the 7 classes, which correspond to kind of abnormalities in the breast. It is important to point out that before to carry out the classification task, it was necessary to balance the data. The oversampling technique was used. Getting the attention layer of the model, a map was plotted, and as can be seen, the model rounded the edge of the breast with greenish yellow patch, an overlap of dark blue patch over the breast tissue. The same took place in the right image, however, it was misclassified. In spite of the proper performance of the attention mechanism, it didn't represent a significant improvement of the classification task. Therefore, the false positive rate is close to the rate in real life, 10%. In this study, a breast cancer classification model with an attention mechanism was replicated in order to get a baseline for our experiments and improve upon these results. The previous stage of digital image preprocessing will be considered for improving the performance of the attention mechanism. In the same way, it is necessary that the model classify abnormalities as malignant or benign. Likewise, it is necessary to enrich the dataset with more samples and ensuring there is no leaking between the training and validation set, that is, using another approach to make balanced data. Thanks to the Colombian Ministry for Science, Technology and Innovation for their financial support.